San Andreas has a problem. We all know about it. But I am not talking about the rock's performance in the movie where California splits in half. It is the splitting apart bit that has scientists, the rock, and even Google thinking. The San Andreas Fault is one of the most dangerous geological features on Earth, 1,200 kilometers long, running directly beneath some of the most densely populated land in the United States. And it has been building pressure silently for centuries. The question scientists have been trying to answer for decades: when does it break? Google tried to solve this problem. They threw their data infrastructure and 2 billion Android phones at it. But instead of predicting the next earthquake, they realized the best they could do was build a warning system. On June 24th, a 7.5 magnitude earthquake struck Venezuela. Thousands of phones buzzed before the shaking arrived. It wasn't prediction. The earthquake had already happened. Remarkable engineering, but the ground had already moved. It can save thousands of lives, but it's still a quiet admission that prediction, knowing before the ground moves, remains out of reach. Satellites, AI, supercomputers, the most sophisticated seismic networks ever built. What stops us from seeing it coming? In 1985, scientists publicly predicted with 95% confidence a magnitude 6.0 earthquake at Parkfield by January 1993. The earthquake arrived in September 2004. 11 years later, zero precursors detected. Early warning means the earthquake has started. You're racing it. Google solved that. Forecasting can tell there's a 70% chance of a major earthquake in San Francisco in the next 30 years. Useful, but can't tell you when. Prediction means exact time, place, magnitude, days or weeks in advance. Nobody has ever done it. 3 of the deadliest earthquakes of the 21st century hit regions' hazard maps classified as low risk. Japan's hazard map, less than 0.1% chance, expected once in many thousands of years. It happened within 2 years of a forecast. The Haiti earthquake killed 316,000 people on a fault that had not moved in hundreds of years. In 2025, Kyoto University, AI predicted fault failure in a meter-sized rock, sealed lab, sensors millimeters away. A result never replicated on an actual fault system. Earthquakes originate up to 10 miles below the surface. SAFOD, deepest fault observatory ever built, reached 2 miles. One location, stopped 2007, never repeated. The stress state on the fault can't be measured remotely. Not satellite, not tomography, not scanning, needs physical access. And that's our understanding of land. What lies under the oceans is a different story. The 2004 Indian Ocean tsunami, more than 200,000 deaths, originated under the seafloor. Our records cover 120 years. Most faults rupture every few hundred to thousands of years. AI needs data that doesn't exist. Early warning? Solved. Forecasting? Improving. Prediction? Exactly where it was in 1985? Nowhere. The Earth keeps its records on a timescale we cannot afford to wait for. The ground doesn't care how good our computers are.